Good morning everyone. My name is Aditya and in this video we will be solving question 1 of homework 6. So we have x and y have joint density function where f of x and y is given by 1 plus xy by a in the range x is less than mod of x is less than 1 and mod of y is less than 1 and it is 0 otherwise. So in the first part of this question, we find a so that the above function is a valid joint density function. So we know that for the function to be a valid joint density function, integral um, with integral of the function with respect to x and y equals 1. So here we have the formula integral minus 1 to 1 because it's mod x is less than 1, so we know the limits are minus 1 to 1. So integral minus 1 to 1 integral minus 1 to 1 f of xy dx dy equals 1. So now we just substitute the value of the function, and first we take the function integral of the function with respect to x. So it's 1 upon a, so integral 1 upon a with respect to x is x upon a plus integral x into y by a is x square by y by 2a, and therefore we have okay, let me just rewrite this. So okay, so thus we have thus we integrate it with respect to y, so we have 2a by y and the limits are minus 1 to 1. So by substituting the value we get 4 by a equals 1, so which gives that a is equal to 4. So we solve the first sub part where we have to find the value of a. So in the second sub part we find whether x and y are uncorrelated. So to find if they are uncorrelated, the simple formula expected value of x and y should be equal to expected value of x into expected value of y. So first we start by finding out this. So for this we have integral minus 1 to 1 integral minus 1 to 1 xy into, because both of them are here, so we use xy into value of f of xy, which is 1 plus xy by a. So 1 upon a is constant, so we can take it outside. So xy plus x square y square dx dy. So here we just integrate it first with respect to x, what dy. So first with respect to x and then with respect to y. So we have, and we substitute the value 1 upon a, which is where a is 4. So basically we get expected value of xy as 1 upon 9. So now we have to find the expected value of x. So expected value of x is given by integral minus 1 to 1 x into f of x, where f of x is 1 plus xy by a dx. So we know 1 upon, we just take 1 upon a outside and substitute the value of a, and we just integrate with respect to x. So after integrating we get e of x is 0. Now since e of x is 0, whole side becomes 0, and e of xy unfortunately is not 0, it's 1 by 9. So we can say that they are not uncorrelated, and also if they are not uncorrelated, this also says that x and y are not independent. So we move on to the so we got the third part, which is they are not independent. So we move on to the fourth part. So we have to find joint density function of x square and y square. So for this we first we assume that z equals x square and w equals y square. Now so z is plus or minus x and w is plus or minus y. So j of xy is partial derivative of z by x. This should be daba actually. So daba z by daba x, daba z by daba y, daba w by daba x, and daba w by daba y. So now so z with respect to x, so which is going to be 2x, right? X square's derivative is 2x, and there's no term in y, so it's going to be straight up 0. No term of w with respect to x. So it's going to be 0, and daba w by daba y, so y square, right? So 2y. So j of xy, we have 4xy, and x is root z, and w is root y. So so we have it in this formula. So we have jx of y is 4 into root z into root w. So to find function of z and w, we have a simple formula. Function of zw equals function of z xy upon j of xy. So now we know that xy is root z and root w, so we can substitute the values. But the only problem is z can be negative root z or positive root z. So for that we have two conditions, and w could be same for w. We have positive root w or negative root w. So basically we just add up the four conditions, and by adding up the four conditions we get we couldn't take this common outside, so we just take it common and add everything. So f of z, we get as 1 by 4 root 2 into root w for z in between 0 and 1 and w between 0 and 1, and it is 0 otherwise. So here we got the joint density function of x square and y square. So in next subpart, in the fifth subpart, we have to find out whether x square and y square are independent. So we use the same thing. We just find out whether f of z with respect to z and f of w with respect to w is um, the multiplication of those two is equal to this. So here we have f of z with respect to z. So which is z into f of x into f of x, right? So for that we have two values, z root z and minus root z for x, right? So here we use both the values, and we get 1 by 2 root z, and for w similarly we get 1 by 2 root w. So so the total is 1 by 2 root w into 1 by 2 root z, so which is equals to 1 by 4 root z root w, so which is the value of function of w and z. So both sides match, so we can say that x square and y square are independent. So here we solve the first question. Thank you so much for watching.